Good evening to everyone. So like Sir has mentioned, we are going to look at some of the concepts which are associated with green buildings. So just to give you a background, so I think many of you all might be familiar with the Indian Green Building Council. So IGBC was formed by the Confederation of Indian Industries in 2001. And the vision of IGBC was to enable a sustainable built environment for all and to make India as one of the global leaders in terms of sustainable built environment. So our headquarters, which is in Hyderabad, was actually inaugurated around 2004 by late Dr. APJ Abdul Kalam. And it was actually envisioned as a demonstration building where we wanted to practice what we preach. So when it was constructed in 2003, it was the world's, India's first platinum-rated green building. And it was the greenest building in our country at that time. And even today, we have a lot of visitors who come to take a tour of the building and to understand what are all the green features which have been implemented in our premises. And also we went one step ahead, and in 2019, we have achieved the we have achieved the net zero energy rating for the particular building. So this was achieved by, we have installed these bifacial solar panels on the rooftop, which was able to offset whatever energy was consumed by this particular building. So to give you an understanding of the green building movement in India, so what started in 2001 with this one green building of around 20,000 square feet, it has grown now to almost 10.42 billion square feet of green building footprint with over 11,500 projects which have adopted these IGBC ratings. And we have developed these IGBC ratings for different typology of buildings. So you have IGBC ratings for commercial buildings, you have for residential buildings, you have for industrial buildings, you even have IGBC ratings available for metro stations and railway stations also. So the main intent was that all of the places where we stay, live, and work, all of them should go green. So what exactly is a green building? So a green building is one which conserves the natural resources, and it also uses less water in its operation, and it optimizes the energy which is conserved in the particular building. It generates less amount of waste, and it also promotes the healthy environment and improved indoor environment quality. So the notion which everybody has usually is that green buildings usually are cost more compared to any conventional building. But it is important to understand that we have to look at the life cycle cost of the particular building. So all of the operational savings which you may be having in terms of the energy, in terms of water, so all of this will offset whatever initial incremental cost you might be having. So we have done an kind of study to understand what is the incremental cost which is associated with a platinum-rated green building. So if you see back in 2003, this was about 18%. And this was majorly because many of the innovative technologies and solutions were not available in India. So most of it had to be imported. But over the years, if you see, a lot of technologies are available in our market itself, and a lot of innovative products are available. So this incremental cost has further come down, and right now it's almost about only 1 to 2% of an incremental cost when we are looking at a IGBC platinum certified building compared to a conventional building. And looking at the environmental impact, which is associated with 4,000 certified projects under IGBC, it is we have anticipated, an energy savings of about 23 billion units per year. So this is equivalent to 10 million urban homes. And in terms of water savings, it is to the tune of 73 billion liters per year. So which is almost equivalent to 1 month of water requirement of Hyderabad. And in terms of the emissions reductions, it offsets almost 19 million tons of carbon dioxide emissions per year. So this is equivalent to almost 9.1 million cars which is taken off the road. And So with respect to the green buildings, you have tangible benefits as well as the intangible benefits. So we also have some kind of intangible benefits associated with the green buildings, like you have the enhanced occupant comfort, there is increase in productivity. This is majorly attributed to the indoor environmental quality of the spaces. So just to give you an understanding of the impact which the building and the construction sector has. So if you look at the graph, you can see that almost 28% of the global carbon dioxide emissions is from building operations, and around 11% of the global carbon dioxide emissions is from the building materials and construction. So overall, around 40% of the global CO2 emissions is from the building and construction sector. And in terms of energy consumption, the sector contributes to around 25 to 40%. And in terms of waste generation, around 30 to 40% of the waste is generated by the construction sector. And in terms of water pollution, it contributes to around 20 to 30%. So this kind of gives you the understanding of the impact which the sector has and the need for us to go sustainable. So it becomes very important for us to make the built environment going green. So right from green buildings to all the way to green cities, we have to design in a sustainable way to ensure that we reduce this impact on the environment. So let's look at some of the concepts which are associated with green buildings. Yeah. So natural topography or vegetation is very important in any project. So this is majorly because this vegetation helps in promoting the local biodiversity. So wherever possible, you have to ensure that you're trying to preserve this natural topography or vegetation which is there on your site. And if it's not possible to preserve it, you can look at ways in which you can incorporate it as part of your design. You can have it over built structures, you can have it as a part of terrace roofing, or you can have it as on top of podium. So you can look at various ways in which you can integrate your design with the vegetation. And heat island is another phenomenon which is prevalent in major metro cities. So this is majorly attributed to the development which happens in urban cities. So what happens is most of the cities are like concrete jungles. So there is a lot of concrete surfaces which are prevalent. And these concrete surfaces, they absorb the solar radiation and they emit it in the form of heat. So because of this, there is an increase in the ambient temperature. So if you look at the graph, you can see that the ambient temperature at the city where there is a lot of urban development is higher compared to the nearby suburban or the rural areas where the temperature is much lesser. So we have to look at how we can mitigate this heat island effect. So let's look at two ways in which we can mitigate this heat island effect. So one is the non-roof areas and the other is the roof areas. So your non-roof areas in your project consist of all of your paved areas, which include your driveways, your pathways, your parking spaces, etc. So all of these spaces, you have to ensure that you try to shade these spaces with the help of tree cover, or you can look at how you can use some kind of open grid pavers or grass pavers. So what happens in open grid pavers is that there is this gap which is there prevalent between two pavers. So this gap basically acts as a thermal break and it prevents the conduction of the heat. And in terms of grass pavers, so these are both aesthetical and also they help in providing a cool environment. So these are some of the options you can consider in your non-roof areas for mitigating the heat island effect. And coming to the roof or the terrace area, so you have to consider high reflective materials on your roof area. So these can be either high reflective paints, or you can have high reflective tiles, or you can even consider something as simple as a China mosaic roofing, which you can provide with, we can reuse all your broken tiles and you can provide a China mosaic roofing. Or you can also look at how you can have a roof garden. You can have a vegetative roof on your terrace. Or you can have a combination of both of these. So this is an image of a terrace garden in a project called Godrej Bhavan. So this is a thermal imaging. So basically the colors indicates the surface temperature. So the red color indicates a higher surface temperature, and green and the bluish shades indicate a lower surface temperature. So if you look at this particular thermal image, you can see that all of the vegetated spaces are at a much lower temperature. This is because it reflects the solar radiation. And whereas the tandoor tiles, which is at a, around, it's red in color because it's at a higher surface temperature as it absorbs this particular solar radiation. And water is another very important concept when it comes to green buildings. So basically, we have to follow the 3R principle when it comes to water efficiency, which is recharge, reduce, and reuse. So generally, we have the tendency of always drawing water from the groundwater sources, and we do not replenish these sources. So we have to ensure that we have rainwater harvesting structures in the project to replenish these groundwater sources. And we also have to look at how we can choose efficient fixtures in washrooms, etc., so that you can reduce the water which is being consumed in your building. And the third R, which is reuse, is basically whatever wastewater which is getting generated in your building, you have to look at how this can be treated and it can be reused again for flushing purposes or for irrigation purposes in your project. So the first R, which is recharge. So in terms of rainwater harvesting, there are two options which are available. Either you can look at how you can collect the rainwater in your site and reuse it in terms of you can have a pond or a water body, or you can have a storage tank. And you can channelize all of your stormwater drains to collect at this particular point. Or another option which is available is the recharge. So in recharge, what happens is you are letting this rainwater to recharge the groundwater table. So you can plan for percolation pits or bore wells, which will help you in recharging the groundwater sources. And so coming to the second R, which is reduce. So we need to look at the plumbing fixtures which are being used in the project. So there are two types of fixtures. One is the flow fixtures and the other is the flush fixtures. So your flow fixtures are all your taps and your health faucets and your showers. So, and the flush fixtures are your water closets and your urinals. So for the flow fixtures, you can consider using aerators. So aerators are very economical and they are easy to fit in any of your fixtures, and this will help in reducing the water flow from that particular fixture. So basically it restricts the water and reduces the water which is coming out of the particular fixture. And in terms of flush fixtures, you have many new technologies available, like you have dual flush systems which works on, based on the need basis, you will have half flush or a full flush. And in terms of urinals also, you have many new technologies like sensor-based urinals and waterless urinals, which optimize the water which is being consumed by the particular fixture. And another important aspect in terms of water conservation would be your irrigation requirement for your landscaping. So it is important that you choose the right kind of species in your landscape design so that you optimize your irrigation requirement. So generally we go for exotic plants and we go for flowering species, etc. So these generally have a high watering requirement and high irrigation demand. So instead we have to research on what are the native species which are available in that particular region, and we have to opt for these species. So these native species, they generally require watering only in the initial stages of their sapling stages. And post that, they generally survive on their own based on the rainfall pattern of the particular region. And you can also consider drought-tolerant species like cactus or some varieties of palms. So these also require very less water requirement. And the third type which can be considered is your adaptive species. So adaptive species are not native to a particular region, but they have been prevalent in that region for over hundreds of years, and they have adapted to the climatic conditions of the region. And they are also, having very little water requirements. So these three species you can consider while developing your landscape design, and you have to try to avoid your exotic species to reduce your irrigation water demand. So one aspect with respect to irrigation would be the landscape design, and the other aspect is what is the kind of irrigation system you're going to use for the irrigation requirements. So again, you have to choose an efficient irrigation system. So there are two types of systems you can consider here. So one is the sprinkler system. So the sprinkler system is advisable for turf areas, and this can reach out to a larger surface area with a very little water input. So compared to a conventional hose pipe, the amount of water it uses to water the turf area is very less. And the drip irrigation can be considered for your other types of vegetation like your shrubs and your trees, etc. So the drip irrigation, basically you have pipes which are laid across your vegetation beds, and these have holes from which the water drips to the root zones. So these are some of the efficient technologies, irrigation systems which you can consider compared to a conventional hose pipe system. And coming to the third R, which is your reuse. So wastewater treatment is how we can treat your wastewater which is generated in your site, and then we can reuse this particular water for your flushing purposes or your irrigation requirements. And there are two types of wastewater treatment which is available. One is your biological treatment, where you use plants, the root zone of the plants, to treat the wastewater, or you can go for a mechanical treatment with the help of a sewage treatment plant. And in both of the processes, the important process which happens in either of them is the aeration process. So in aeration process, what happens is you're basically adding air to break down the waste particles which are present in the water. So if you look at this particular photo, this phytoremediation plant is from our headquarters. And if you see, it might look like just like a garden, and even if you walk around it, there is no foul smell which will emanate from this particular phytorem plant. And if you look at the process chart which is provided there, you can see that it basically has two chambers. One is the filtration pond, and the other is the polishing pond. So the filtration pond is your primary treatment chamber, and that is where the plants which are present in this particular primary treatment chamber, they absorb the oxygen from the atmosphere, and through their roots, they emit this particular oxygen. And this oxygen will treat the wastewater and break down all the impurities, and it will purify it. And this process is again repeated in your polishing pond, which is your secondary treatment chamber. And once it comes out of your secondary treatment chamber, this water can be stored and it can be reused for your landscaping or your flushing purposes. And energy efficiency is very important when it comes to green buildings, because energy takes up most of your energy with respect to HVAC and everything, will take up most of the operational energy used in a particular building. So how to optimize this particular energy which is being used in your building? So you can look at passive architecture. So when it comes to passive architecture, even simple things such as your orientation will play a major role. So basically, if you see the sun path diagram for most of the spaces in India, the sun travels from the east to west from your southern side. So the major exposure is on your southern and your western facades. So you will have to ensure that you minimize your openings on the southern and the western facade so that you can reduce the heat gain into your building. And also you can plan for your buffer spaces or your service areas like your staircases and your washrooms and your utility spaces on these particular, regions, in your southern region and in your western region. And everybody knows the importance of your vertical fins and your horizontal overhang. So they also have to be properly designed to ensure that your heat gain inside your building is reduced. So there are also some passive technologies which are available, like for example, these earth air tunnels. They basically work on the principle that the earth remains at a constant temperature of about 22 degrees Celsius. So in this technology, you take pipes to around 4 meters below the ground. So when your ambient air is around 30 to 35 degrees Celsius and the hot air is taken through this pipe to 4 meters below the ground, it gets cooled by the earth, which is at a much lower temperature of around 22 degrees Celsius. And then this cool air can be taken to recirculate inside your building. So this also works in cities with extreme climates where you have winters which are really cold. So when your winters might be 4 or 5 degrees Celsius and your earth is still at the constant temperature of 22 degrees Celsius. So again, you can take this cold air from your outside to 4 meters below the ground and it gets warmed up. And then this particular air can be taken to recirculate inside your building. And wind tower is another passive technology which can be used for passive cooling. So basically what happens in a wind tower is that there is hot air which enters from the top of the tower and you have mist sprayers which are located at the top. So these mist sprayers spray water particles and they cool down this hot air which is entering from the top. So this hot air starts to settle down. And on the other hand, you have a solar chimney. So this solar chimney, what happens is it heats up the air which is inside your building and it causes it to rise. And there is a pressure difference which occurs and it makes the cold air from the wind tower to come inside your building. So through a wind tower, you can anticipate a drop in air temperature of around 4 to 5 degrees Celsius. And coming to building materials, so in all of your projects, you have to look at how you can reduce the dependence on virgin materials. So wherever possible, you have to look at, if it's an existing building, you can look at how that building can be reused. Or if it's a new development which you're coming up with, you can look at how you can reuse salvage materials, or you can use materials with recycled content. Or you can also look at how you can source locally available materials, which will help in reducing the carbon dioxide emissions which are associated with transportation of materials. So this is an example of a project which is the Ambuja Cement Corporate Office. So generally, the structure of particular building has a life of around 60 years. So what happened over here is that they've gone for a major renovation and they have retained the structural elements of the particular building and they've only done renovation in terms of your envelope and in terms of your interior. So in this way, they have reduced the virgin materials which they have used in the project. And you can also consider, reusing salvage material. So this is an example of the Aisher office in Gurgaon, where they have actually bought these railway sleepers from a railway auction, and they have used it as the double skin for the particular project. And there are also some photographs showing how pipes can be used along with your lighting fixtures, and the empty paint cans can be used for storing documents. So you can look at how you can salvage materials and reuse in your project. And coming to wood-based materials, you can consider two types of products over here. So one is the rapidly renewable materials. So rapidly renewable wood is something which can be harvested in less than 10 years. So these includes like bamboo, bagasse, and eucalyptus kind of species. And the other option which can be considered is your certified wood. So certified wood is basically wood which is harvested from forests that are responsibly sourced and managed, and these are environmentally conscious. And in terms of waste generation, so during the project construction, it is important that you manage the waste which is getting generated in your project. So first, you will have to look at how you can minimize the waste which is getting generated during your construction. And the waste which is getting generated, you need to properly segregate it and store it on your site, so that you can look at how this waste can be reused in your site. Like, for example, broken bricks and all can be reused for your backfilling, and broken tiles can be reused in your pavers, and even for your terraces it can be reused. So you can reduce the amount of waste which is being sent to the landfill. And then the waste which is after reusing whatever waste is possible, the leftover waste, you have to look at how you can associate with some kind of a recycling vendors who can take up this waste and they will use it for recycling purposes. And you can ensure that this waste is not being going to the landfill. And there are also some kind of construction technologies which are available where the amount of waste which gets generated itself is very less. Like for example, in prefabricated construction, so these are, over here, the panels are actually prefabricated and then they are just coming and being assembled on site. So the amount of waste which gets generated during construction is very less. So you can also look at how you can, consider these kind of technologies in your projects. And there is also 3D printing technology, which is another technology which can be considered. And the other aspect of waste is the waste during the operations phase of your building. So you will have to ensure that you properly segregate this waste and you recycle it so that you can have a circular economy. And there are many advanced systems available for waste management. So you have these kind of automated solid waste management systems where the waste which is getting segregated at the source, so they can be sent to these chutes. These pneumatic chutes, they work based on the pressure difference. So these pneumatic chutes, they run across all of the floors. And so these waste can be sent to these chutes and it gets collected in a central location. And from there, the vendors, the authorized vendors can pick it up for further processing. And organic waste is also something which can be, Organic waste is also something which can be managed in your site itself. So organic waste includes both landscape waste as well as the food waste which gets generated in a project. So you can look at natural processes like vermicomposting, which uses earthworms to break down these particular into manure, or you can also look at leaf composter. And on the other hand, you also have mechanical processes available like the organic waste converters. So over here, what happens is there is a shredder first, which shreds all of the waste, and then a biocompost is added along with this particular organic waste to break it down further. And this raw compost is stored in these curing racks. And after this curing, this output from this particular machine can be used as a manure. So you can use it for your landscaping purposes. And indoor environmental quality is one of the intangible benefits, which are associated with green buildings. And it is majorly affected by 3 parameters. So one is the air quality, the other is the materials which are used in your building, and the third is the connectivity. So connectivity would be in terms of, the connectivity to outdoors, the kind of daylighting you have in your building. So all these 3 parameters determine the indoor environmental quality. And any building which has a poor IEQ is associated with something called as the sick building syndrome. So a sick building syndrome is a medical condition where people in a particular building, they suffer from symptoms of illness or they feel unwell for no apparent reason. So this is majorly attributed to the poor IEQ of the particular space. So fresh air ventilation is the most important parameter when it comes to indoor environmental quality, as it ensures the comfort of occupants and well-being of occupants, and it increases the productivity of the occupants. So CO2 monitoring is an important concept which should be incorporated in projects to understand what is the indoor air quality of the particular project. So you can see here there are 2 cases which are being presented here. So in the first case, the carbon dioxide outside, which is in the ambient conditions, is around 400 parts per million. And the CO2 levels within your building is around 1,400 parts per million. And if you look at the case 2, the carbon dioxide at ambient is around 400 parts per million, and within your building it's around 930 parts per million. So the general thumb of rule which we follow is that the difference in the carbon dioxide levels between your inside and the outdoors should not exceed 530 ppm. So based on this thumb rule, if you see, the case 2 has a good ventilation system because it's maintaining a ppm difference of around 530, whereas case 1 is having a poor ventilation system because of it has a difference in ppm of around 1000 CO2 CO2 levels is difference is around 1000 ppm. So this plays an important role in understanding whether your ventilation system is contributing to the indoor air quality or not. And another aspect which is important aspect with respect to ventilation is your demand control ventilation. So generally, if you see the general conventional ventilation systems, they are predefined. They predefine the amount of fresh air which needs to be sent to the different spaces. Whereas what happens in a demand control ventilation is the ventilation demand is determined by the carbon dioxide level in that particular space. So the fresh air is adjusted based on the occupancy in the particular space. So if you look at this picture which is shown here, the occupancy in each floor is varying. So based on the occupancy, the CO2 level will vary in the various floors. So based on the CO2 level, the fresh air is varied. So for example, in floors 1 and 4, where there is more occupancy, there is more amount of fresh air which is being provided to these spaces. And whereas in floor 3, where there is very few occupancy, so the amount of fresh air which is supplied to the space is less. So this is an important system which can help in saving a lot of energy if implemented. And daylighting is another important aspect which will help in providing a better indoor environmental quality. So a light pipe is one of the techniques you can consider for deeper penetration of daylight in the interiors of this building. So a light bulb basically has a collector on the rooftop, and it has a highly reflective pipe. So through this pipe, the the light rays which gets collected from the roof gets reflected to this pipe, and it can be diffused into the interiors of the building. So this is a technique which can be considered for interior spaces where you want daylighting. And light shelf is also another technique which you can consider for deeper penetration. So generally in conventional windows, probably the daylight can penetrate to about 30 feet or so. So with the help of light shelves, so these light shelves are again lined with reflective material. So this will help in deeper penetration of the daylighting into the interiors of your space. Yeah, so with that, I come to the end of my presentation, where I just wanted to cover the various concepts which are associated with green buildings. And if you have any questions or you need any information, you can always write to me. Yeah, thank you.